In this video, I'm going to be making a homemade sensor to know when my garage door is up and when it's down. That's coming up right now on this episode of Retro Hack Shack After Hours. Well, hey everybody, my name's Aaron. This isn't the usual location that you might expect to see me, or I'm also not behind the camera right now, as I usually am on this channel. I'm actually over here by my two garage doors. Now, as you might expect, the Retro Hack Shack is in a garage. You probably figured that out by now. And in the Retro Hack Shack, I have lots of computers. Some are valuable, some are not, but I do want to keep them all protected. And I'm also getting to the age where it's kind of hard to remember sometimes, did I leave the lights on or not? Did I leave the garage door open or is it closed? Sometimes I'm not sure. But with home automation, it's easy to figure this out. I've been using some off-the-shelf sensors that are meant for windows and doors to alert you over the Zigbee network to figure out whether your doors are open or closed, but those rely on tiny batteries that you have to replace every so often. Also, I found that Zigbee network isn't always that reliable, and so sometimes my sensors will go offline and I have to go reconnect them or reconfigure them on the network to get them working again, and it's been kind of a pain. So the other day I wandered over here and was just thinking, what could I do to improve the sensors on my doors and get them to notify me when the garage door has been left open for too long? And then I remembered that I have this. Yes, it is a metal tin can that Microsoft Flight Simulator used to come in, but it's actually also my sprinkler system. It's the sprinkler system I created using some relays and a Raspberry Pi Zero. And that got me thinking, since I already have the Raspberry Pi Zero here, perhaps I could use the Raspberry Pi to interface with my home automation system and use something like a reed switch that would go ahead and basically do the same thing. If I build my own sensor using a reed switch and hook it directly to this Raspberry Pi that always has power going into it, I won't have to worry about batteries ever again. And if something goes wrong, I will have written the code, so I should be able to go in and troubleshoot and make sure that it's always working. So let me show you what I've been working on, and we'll go test this. I'll show you the programming. I'll also show you how it interacts with home automation. I can't go through every step of installing all of these things. You're going to have to learn some of this yourself if you want to duplicate what I'm doing, but it should give you a good idea of how this works and might give you a few ideas of how you could use magnets and reed switches and microcontrollers or Raspberry Pis in your projects in the future. So let's get started. All right, well, I'm going to need something to test with, and so I just grabbed a random Raspberry Pi out of my Raspberry Pi bin. This happens to be, I think, a Raspberry Pi B Model 3. Not quite sure, can't read it from this distance with one eye, but these Pis, I've actually found two of this model Raspberry Pi at e-waste where people had just thrown them out, and I took them home, cleaned them up, plugged them in, and they just worked. And these Raspberry Pis, even though they're old by today's standards, it's not a Raspberry Pi 5, but these Raspberry Pis actually are great for testing out code and doing things that where you don't need a lot of graphics. If you just need a Linux computer running a text environment where you're going to be doing some scripting and things, this actually works just fine. Like I said, I'm running my whole sprinkler system for my house on a Raspberry Pi Zero, first gen Raspberry Pi Zero. So these are actually pretty nice, I think, to keep around just for stuff like this. So I'm going to be using this for doing my testing of my scripts today. I have it set up with my shutdown button. I think I included this in my book, in my Raspberry Pi book, which is called Linux for Makers. And I think I included how to do this shutdown button as one of the projects you can do. For the older Pis before the Pi 5, it was pretty important that you shut down in an orderly fashion and not just pull the plug out of this, because you can mess up your system. You could get it not to boot again because the SD cards that are used in this, the interface isn't fast enough necessarily to keep up with all the changes. And you pull out the plug and it's in the middle of writing something, and then it messes everything up, and for some reason you can't boot after that. That's happened a lot of times with these old Pis. Anyway, in my book I included this little shutdown thing, so that's what this button is up here on the GPIO. And then I went ahead and hooked up a reed switch. So this is a reed switch. They are pretty delicate if you get these. I don't know if this is the old style, new style. I just happen to have these in my parts collection. And this is glass. So if you manipulate these leads too much, I already broke like 4 of them just because I was putting too much pressure on them, and they break pretty easily. Think of it as being even more delicate than those old school incandescent Christmas tree light strings, right? Where, you know, the bulbs on those are pretty thin glass and they break pretty easily, like if you step on them or whatever. This is even more fragile than that. If I put too much pressure on these pins here, I'm not going to do it now, this glass will break. So anyway, but I have hooked this up just to test with. And the way the reed switch works is there's 2 pieces of metal in there, and when you get a magnet close to this, it will cause the 2 pieces of metal to make contact, and that will short these 2 wires together. So I've got one side of this hooked up to ground. I've got another side of it hooked up to a GPIO pin. In this case, I think it's GPIO 4. And yeah, so basically the way this is going to work is when the garage door is closed, this will be close to a magnet. The magnet will cause this to be closed and send a signal back to my program running on the Pi, which will then be able to communicate with my home automation system and tell it that the door is closed, or vice versa. And then we can do some more fun things after that. But this is what I'm going to be using for my test environment. Let me give you an overview of how my system is hooked up. We'll go through the code, and I'll show you the configuration that I used in Home Assistant to actually get this working, so that you can either follow along, copy what I did, or maybe use that as a basis for your own project. We're going to go into all the details in just a minute, but if you're interested in home automation projects, you should check out the project page at PCBWay.com. PCBWay offers low-cost, high-quality PCB manufacturing and a whole lot more. One of my favorite features on PCBWay's website is their project page, where the community can upload projects. You can browse these and order these particular parts so that you can use them yourself. Or you can create your own project by uploading your design and receive 10% back when someone else orders your particular project. So check out PCBWay for all your PCB manufacturing needs, and I thank them for their support of the Retro Hack Shack. All right, well, I wanted to take a look first at the setup that I have in the house. And so without having to draw something out really complicated, taking a long time, I just asked ChatGPT to come up with something, and I gave it instructions for adding some light switches and some windows and some doors that I could be controlling. Well, it came up with an interesting diagram. I will give it that. The most interesting thing, I think, is this oil derrick that's right now right above my head, or not an oil derrick. What is that thing? Like I don't know, like a radio tower or something like that. Some sort of radio tower. It says window on it, but it's obviously not a window. So yes, it's drilling for oil on top of my head. So yeah, pretty funny. ChatGPT did a good job. We're just going to go with it though. So I do have a Linux server that is running Home Assistant, and it's also running Mosquito, which is an MQTT broker. I'm not going to go into too much details about what these things are. Home Assistant, maybe you've heard of, maybe you haven't, but it's a program that allows you to control things around your house, set up routines and things like that. And MQTT is a protocol. It stands for Message Queuing Telemetry Transport, I believe. And it's basically a very simple messaging system where you can send messages or subscribe to messages, and devices can say, hey, my light is on, and it will take that message and it will send it to whoever needs it. Or you can, listen in on that particular signal, if you will, and then do something when you see the light switch is on. So I'm going to turn on the thermostat or something. Anyway, it's a very useful protocol, and that's what I'm running on the server to make this all work. And then I do have devices out on my network, on my Wi-Fi network, and also on a Zigbee network. I should have asked ChatGPT to put Zigbee in here too. But these devices communicate either through MQTT or on the Zigbee network to Home Assistant. And I'm using devices like ESP32s for the most part. Sometimes they're devices that are based on the ESP 8266, like the Sonoff devices. I have a lot of those running my light switches and so forth. And those are great. The Sonoff minis are great because they fit in light switches and I can program them and do whatever I want with them. So yeah, you can put a lot of devices on this thing and it works really well. With ChatGPT's help, that's the overview of the network I'm running, just to give you, so you know what's going on here. All right, so I have my Raspberry Pi set up. It has Python 3 running on it, and I just did a quick Python script using some snippets from the web and other things that I've written in the past to get this thing up and running. So let me just show you what's going on. It's using the Raspberry Pi GPIO, of course, because that's where we're hooking up the read switch to be able to see when the garage door is up and down. It's using the time library as well, because I need to do things like wait for a little bit here and there in the script. And it's using something else called the Paho MQTT client. So this is a Python client that you can use to communicate on MQTT. I'm not going to go through every single thing in here, but I will point out a couple interesting things here in case you wanted to set up something on your own. So up here at the top, I'm setting up the pin, the GPIO pin that we're using. We're using pin 4 as a variable. And then I'm using the BCM setup mode for GPIO. That's basically, you can use BCM for to say GPIO 4, or you can use board mode to say I want pin 4 or pin 5 or whatever. So you can either reference the GPIO that you're using by pin or by the GPIO number. In this case, I'm using the GPIO number, which is BCM. Not sure what BCM stands for. And then I'm setting up that switch pin that we made a variable for up here, 4. So I'm saying set up pin 4 to be a GPIO input, and then make it pull up. So there's internal pull up resistors. And what I'm saying is I want that to be pulled up high. I want that pin to be pulled high, because what we're going to be doing is when that switch, that read switch closes, when we put the magnet near it, it's going to connect to ground, and that will cause that pin to go low to ground. It's going to be always pulled up except when the switch comes into contact. That will cause that pin to go low, and that's going to give us the signal we need to know whether the garage is closed or not. Down here, I'm making the connection, the MQTT connection that I need back to my server so that I can send data to it. And then right under that, I have defined a topic. Topic was the word I was looking for before. In MQTT, the topic is what you publish your message on, and then that tells Home Assistant, who's listening to that topic, basically what to do. In this case, the topic is about my garage door. You can make this up. I just kind of used my own. It's a toggle, it's a garage door, and we're looking for the state. Is it open or closed? And so we're going to have to, later on, I'll show you, I'm going to put that into my MQTT configuration. So just keep that in mind. We'll see that again later on. And then down here, what I'm doing is I'm saying, look, if the that switch pin, that pin 4, if that's high, that means that the magnet hasn't closed the switch yet, so the door must be opened. And if that's not the case, if that GPIO input, if that's not the case, if the GPIO input is low, then the garage must be closed because that magnet has closed that switch. The next part of the program here, I do a little print state so that I can see in a terminal window what's going on. That's always helpful. And then I connect to my MQTT server. I say if the state is opened, then publish the payload here, which is on, to the MQTT server. And if it's closed, then we publish the payload off to the MQTT server, and denoting that that is closed. So we've got to keep that in mind. Payload on is open, payload off is closed. And then we disconnect the client from the MQTT server and go about our merry way. And that's pretty much it. It's a pretty simple script here. It does take a little bit of understanding of this MQTT client that we're using, but it really wasn't too hard to put together, and the whole thing is only about 52 lines of code exactly as I have it configured today. All right, so I have uploaded that script to my Raspberry Pi that I'm using to try this out. I've got the read switch connected, and I can go ahead and execute that script, and we'll see if it works or not. Okay, and there we go. And there is these errors we're getting up here is because there's several versions of this particular MQTT client, and I want to use version 1, so I'm kind of overriding the normal API that would be used by this, and I'm saying I want to use version 1. I'm not going to go into the details of why. It's mostly because I'm running old software on the Raspberry Pi and the other versions don't work quite right. So I'm using version 1, and it's giving me a warning here that I'm using version 1. No big deal. Underneath here, we can see that it is GPI, this GPIO setup switch pin nomenclature is here, and then it says that it's opened, which is that print state that we had in the program. So it's evaluating the state of that connection, whether it's high or low, and because there's no magnet, it's staying high because we pulled up with the pull-up resistor saying that that pin is high. And until we put a magnet, it's not going to say low. When it goes low, we should automatically read it again, and it should come back closed. So I have a little magnet. It could be any magnet really that you want to use. I just happen to have this one that came off the door, which is a kind of a weak magnet, but it does work. This was used with one of the older devices that I was using before to try to make this work, and it kept failing for various reasons, as I mentioned. So I'm just going to hold this close. In fact, I've got kind of a long cord here, so hopefully you can see it. Here's the read switch. And I'm just going to go ahead and hold this close to the read switch. And when I did, it says closed. When I go back, move the magnet back a little bit, it says open. Closed, open. Closed, open. All right. So the script is working and the read switch is working. So let's go now and take a look at Home Assistant, and I'll show you what I've got set up there. So this is a portion of my main Home Assistant dashboard with, like I said, I've got all kinds of stuff set up on this thing, power switches. You can see some IKEA outlets, all of the lights, my kitchen lights, my living room lights. There's all kinds of things on here. And I even use this in production in the garage. I've got a couple of fill lights here that I use that I can turn on and off at the touch of a button on my phone, and it'll turn the fill lights on in the studio in the Retro Hack Shack in the garage. But what we're interested in is the garage door. So you can see that right up here. There's the control that I have hooked up to open and close the garage door. And then there's the garage door state, which is now open. And then there is this alert, and we'll get to that in just a minute. But you can see if I take my read switch and I hold the magnet up to it, it should go closed. Yep, there it goes. So it is communicating that quickly with the MQTT server, which Home Assistant is using to read the state of the device that I set up. And you can see when I do that, it toggles from open to closed. Let's switch now to the server that I'm running Home Assistant on, and I'm going to show you the portion of my configuration that is set up to make this work. And we'll talk about the alert that's running because that's going to be very important, or kind of neat actually, to remind me that the garage door has been left open too long. Okay, so this, what we're looking at now, is the end of my YAML file, and this is my configuration for Home Assistant. Again, not going to go into great detail about how this works. You can learn that on your own, but I do want to show you the pertinent bits that relate to what we're doing here. So I set up a binary sensor, and you can see this is indented because it's under my MQTT configuration in my configuration file. So this is a sub item under there. And this other stuff up here is other things that are going on that I've set up. But down here, I've set up a new binary sensor. I've called it garage door state. And in fact, behind me here, you can see that is reflected right here, garage door state on my dashboard. And here's that state topic I mentioned before in the program that we're running, the Python program, toggle garage door state. So you got to have that in there, otherwise it's not going to work, but this is how it's going to know what's going on. And then the device class, which is opening. There's different device classes. I don't understand them all, but I know that opening is for something that opens and closes. So I put opening because the garage door opens and closes. Could be a window or other things that open and close like that. So that's really all you need is a binary sensor. It automatically, the payload, if you remember from the program that said on or off, that is the defaults for this binary sensor is on or off. That's why I'm using on and off rather than open and close as the payload, because that way I can keep my configuration nice and tidy and don't have to change anything. So it's just a choice that I made. You could change that if you wanted to add a couple lines here, define your payloads, and then you could change that in your script, but I figure why not just go with the defaults. Underneath that, we have this alert. So this is an alert that I set up. I'm calling it garage door, and the name that I'm giving it is garage is open. And if we go back here again and look behind me here, here's that alert that I have, garage is open. I also have a done message. This will become important in a minute. Garage is closed. And I have when we set up this binary sensor, it creates the binary sensor with this entity ID. It's called binary sensor, garage door state. Makes sense, right? With what we've got up here. But it creates that. You can find that in your configuration in your Home Assistant settings. So what we want to do is we want to say, well, when the state of this entity is on, and when it has repeated 20 minutes, this is measured in minutes, this repeat configuration variable here, then it will trigger this alert. And we're going to skip the first one because I don't want to get an alert right when I first open the door. I want the first one to be ignored. And then I want the next one that happens after 20 minutes to be the one that triggers the notifier, which is the last thing here. And that is notifying my Pixel 7 Pro phone. So you can set up a mobile app integration in Home Assistant. So what you have to do is you load the companion app for Home Assistant on your phone, and then you will be able to use this configuration here, this mobile app, and it will actually send a pop-up notification on your phone. And we'll take a look at this in a minute when we test this out and see if it's working. So with all of those things together, then this should work in a little while. When 20 minutes has passed, I should get a notification on my phone that the garage door is open. All right, well, I'm back. I just got the notification, and I actually got several of them. Here's what they look like on my screen. You can kind of see that there actually got 3 of them. They say garage door is open, and if I tap one of these, come on, it should bring up Home Assistant, and there is the garage door thing that we're also seeing here behind me. But there it is there, and you can see the alert is turned on. And if I want to, I can do a couple of things. I can close the garage door, which is what I should do. Or I can come over here. If I work very carefully here, can I do it? Yeah, I got it. So now I turn that little switch off, and that will silence the alarm. And if we look behind me here at the screen, you can see that it also is ticked over here on my desktop. So the phone and the desktop, of course, are in sync. And yeah, that alarm is now silenced if I wanted to do that. Otherwise, I could just dismiss the alarm from my phone, and in 20 minutes, I would get another alarm saying that the garage is open. So that's the way that works. I'm going to go take the sensor now, the read switch, and I'm going to go hook that up in the garage, and we'll test it with the real garage door. All right, well, I've taken my old device off the wall, and here it is. You can see it's got a battery that's not quite a 2032. It's something thinner, or maybe this is a 2032, actually. I'm going to take that out because I'm kind of curious whether this just lost battery or why this stopped working. Like I said, I've had to reset it several times. I've had to put washers in here to keep the battery connection tight and things. But look what I found on the other side. I don't know if you'll be able to see it on camera, but there is this black thing right here, this long black thing. Guess what that is? That is a read switch. So this device was basically using the same thing. It's got a little microprocessor here. It's probably got a antenna to use to communicate on the Zigbee network. And yeah, it's got a read switch. That's how this one was working, just like we're trying to do with the Raspberry Pi. All right, well, I've gone ahead and ran this wire down into the box here and connected it to the same pins on this Raspberry Pi as I had on the old Raspberry Pi. That way I can reuse the code without any issues. I should have the library set up and the code running at this point. So all I really need to do is measure the distance, how far away I need to get the read switch from the magnets that are on the door. I know you can't see them, but they're on the side of the door here. How far away I need to position the read switch so that I'll know if the garage is open or closed, and then I'll tack this down to the side of the framing here by the door, and should be good to go. If there's nothing inside that would catch on it or interfere with it at all, I'll staple it down and make sure it's all tucked away really well. I've also got my dashboard open with my garage door thing that we were looking before, so I should know when this comes in contact. So I'm just going to get it close to the magnets, and we'll see how far away this thing has to be before it will trigger. So getting it closer, closer still, closer.
Come closer! Closer still.
Something is not working here. I'm touching the magnet now. That should definitely be triggering it, and It is not changing the state on my phone. So, let me go back to my desk and we'll log into this Raspberry Pi and see why this isn't working out here. See if it even sees anything going on at all. All right. So I'm connected to the Raspberry Pi Zero that I call Open Sprinkler. And I've got the script to start automatically when the Raspberry Pi boots up, and I changed the code, I rebooted it, it should have started up. So I just want to first verify that the code is actually running. And I called the program readswitch.py. So I'm just going to go ahead and do a ps-ef. And to sort this, because this would output a lot of all the programs that were running essentially, to sort this, I'm going to output this to grep, and we'll put in read and see if this is running. And no, it's not. Now it did return a line there. If you're not familiar with PS, this will return a line because it's returning the grep program, which is looking for read. So what you're seeing there isn't the read_switch.py program. It is the actual grep that I just did for read is showing up as a process. So the command itself is not running. So maybe it's failing for some reason. So let's go ahead and we can just try running it. Python readswitch.py, that should be it. And let's see what happens. It fails, crashes. So, this is saying that it doesn't like the callback API version. And I think what's going on here is this Raspberry Pi that I'm running has a really old version of Raspbian on it. I don't even know exactly what it is, but it's something that's super old, probably like 5 or 6 years old, I think, at this point. And I know I got this module loaded so it can run in the Python program, but maybe it just doesn't have support for this callback API version thing that I'm doing. So let's see. Let me just take that out. Maybe this thing only runs at version 1, and so it doesn't need this. Let's take that line out and see what happens. So I'm going to comment that line out. And then in this other duplicate line that I made, I'm just going to say, I'm going to take that whole thing, all that parentheses out, and just run it like that, which is the way you used to do things in Python. So the way you normally would do it is you create a reference client and set it as part of this MQTT library, which is the client part of the library, just to make it easier to reference that part of the Paho MQTT client library. So let's just save this and see if it runs now. Okay, here we go. Yeah, it looks like things are different in this version of the MQTT client. So I'm going to go through and clean up all of these mismatches here, try to look at some old reference documentation and see if I can get this thing working, because now it doesn't like the way that I'm calling username and password. Okay, and I figured it out. So user error. And if you know Python, you probably caught this when I was changing my code. So when I changed this line right here, I've since redone my file with the help of ChatGPT. Thank you very much, ChatGPT. It's now several lines smaller. But when I went in here and took out the stuff that was in the parentheses right here, I took out the parentheses as well as what was inside. And simple mistake, that's what I did. You need these parentheses to be able to run the program. So that's why it was failing. And yeah, now I think it is running. At least it was last time I checked. Let's go ahead and run this. There we go. And it prints opened. So yeah, the program is now running. It was all human error and AI came to the rescue. So that was a quick solution. So now I'm going to reboot the Raspberry Pi just to make sure that it is launching this script correctly. And then we'll go back out to the garage and see if the read switch is working. All right, moment of truth. I've reset the Pi. It should be running the new code, the fixed code, and let's go ahead and see if this is working. I've also got my dashboard up here, which shows me the state of the garage door. Right now, it says the state is open. And if I move this read switch in close to the magnet, oh, there it goes, closed. Now I back it off, open, and move it in, closed. Wow. Actually, with the bare reed switch, without any plastic or anything in the way, I can actually get the reed switch about an inch, inch and a half away from the two magnets, the two little disc magnets I have placed on the door, and it will activate the door being closed. So let me go ahead and button this up and we'll test it with an actual garage door lift and close. All right, well, I changed my mind. I actually got this cable routed and then I used some blue tape to stick the reed switch in place where I need it for now. I think I'm actually going to come back and 3D print a case, which will do a better job of holding the reed magnet or the reed switch exactly in place where I need it to. I found that because of the magnetic waves that come off of those disc magnets, if I put the reed switch at the top or the bottom of the circle that's attached here to the door, that it triggers close when the reed switch is in that position. But if I hold the reed switch very carefully in the middle of the magnet, because of the way those magnetic waves are, it actually shows as open. So I have to have it offset either to the top or the bottom of those disc magnets in order for it to work correctly. So yeah, I think I'll 3D print something to make sure it's in the exact place. And for now, holding it on with some blue tape is fine. All right, well, now the only thing to do is to do a real world test. You can take a look at my dashboard here and hopefully you can see that the garage door is closed and the alert is in the idle position. Now I'm going to go ahead and say the magic words. Okay, activate the garage door.
All right, activating the garage door.
There we go, it's going up. There we go. And if I take a look at my dashboard now, of course, it says that the garage door is open. It's a pretty noisy garage door, that's for sure. The alert is currently triggered, and if I was to leave this open for 20 minutes, I'd get that notification on my phone that the garage door was still open. So now let's go ahead and close it and make sure this actually registers close. Okay, activate the garage door.
Got it. Activating the garage door.
And there we go. As soon as the garage door closed, it came up as closed on the dashboard. So this project is now working, and because it's powered by the Raspberry Pi, I no longer have to worry about dead batteries or things going wrong. This is very simple, and it just should stay running forever or until the power for the whole house goes out. And if the power for the whole house goes out, then yeah, I've got bigger problems to worry about. So I would call this project a success. I hope you learned something today or enjoyed watching, and if you did, I'm going to put a link over here to another playlist about mods that I've done in the past that you might enjoy, or you can take a look at this other video that Google thinks you might like to watch after watching this video. Thanks for watching, thanks for supporting the channel, and we'll see you in the next video. Bye.
End of line.